So if we look at the trends in boiling points of groups as we go down them for groups 4, 5, 6 and 7, well, generally we see an increase in boiling points. And that's to do with, as we go down the groups, we have more electrons, some more London forces or Van der Waals forces, whatever you want to call them. But if we look at groups 5, 6 and 7, we have a bit of an anomaly where we see an unexpected increase in boiling points for ammonia, NH3, hydrogen fluoride, HF, and water, H2O. And all this suggests there must be another force at play here. And these forces are called hydrogen bonds. So how do hydrogen bonds form? Well, I gave 3 examples of molecules that form hydrogen bonds in the graph I just showed previously. But in this example, we're going to use H2O or water. So here is our dot and cross diagram of the water molecule, which you would have done at GCSE. And here we have the shared pair of electrons between the oxygen and hydrogen atom. But actually, these electrons aren't just shared equally between the oxygen and hydrogen atom. Actually, these electrons are pulled more towards the oxygen atom. And that's because oxygen is actually more electronegative, which means it has the tendency to attract these bonding pairs of electrons towards its nucleus more than the hydrogen atom. Now, electronegativity is an entire topic in itself, but that's all you need to know for the purpose of this video. And because of this uneven distribution of electrons, we say oxygen is more electronegative, so it has a slight negative charge, and hydrogen has a slight positive charge, as the electrons are more in favour towards the oxygen atom. And this is a polar bond, okay, because it has 2 opposite charges, so it is polar. And because of this polarity, the slightly electropositive hydrogen atom can come close to a slightly electronegative oxygen atom, and these form hydrogen bonds, as we can see by these dotted lines over here. It's important to note that hydrogen bonds are between molecules, not within the molecules. These are the polar covalent bonds, and between the water molecules is where we have the hydrogen bonds. And that is why water, hydrogen fluoride and ammonia have relatively higher boiling points compared to the rest of their group that are lacking these hydrogen bonds. Okay, so I hope this very brief video, has given you a better understanding of hydrogen bonds.